Welcome to day one. Today, we are going to build your very first practical tool, an automated salary hike calculator. We will write a Python script that does the heavy lifting for you. To write reliable code, you need to see exactly how your computer reads and translates the instructions you give it. This understanding ensures your commands achieve the results you intended. Think of Python as an incredibly fast, but extremely literal digital assistant. If we want this assistant to calculate our finances accurately, we first have to learn its specific language and process. If we skip this step, our instructions will get lost in translation, and the whole system will fail. Let's look at how that translation actually happens. Older languages, like C++, are compiled, meaning they translate your entire page of code into a block of machine code, raw ones and zeros, before the program even starts. Python works differently. This diagram shows the first part of Python's unique two-step process. When you hit a run, Python performs a quick translation of your readable code into an intermediate shorthand. We call this shorthand bytecode. The Python virtual machine engine reads that bytecode, translating it line by line into binary pulses your CPU can execute. Because Python reads and executes your instructions line by line, it will keep running right up until it hits a single typo or bad instruction. If it finds one, it stops and crashes mid-task. That means our starting logic must be clear and precise from the top down. To calculate a new salary, our digital assistant needs a place to store your numbers. We use variables for this, which function as labeled storage boxes sitting inside your computer's short-term memory, or RAM. Look at these 4 boxes. They represent Python's foundational data types. The first holds whole numbers, called integers. The second handles decimals, known as floats. The third stores text wrapped in quotes, which we call strings. And the final box is for booleans, which act as simple true or false switches. Older languages require you to stick a permanent label on every box to declare exactly what type of data would go inside. Python uses dynamic typing. Notice how the box here adjusts automatically. Python figures out the data type on the fly, simply by looking at the value you drop into it. If you ever need to check what kind of data is sitting inside one of your variables, Python has a built-in tool to help. By wrapping your variable in a command called the type function, Python will report exactly what kind of box you are currently looking at. This automatic sorting speeds up the writing process and makes your code flexible. However, it transfers the responsibility of tracking those data types directly to you. If you aren't paying attention, it is easy to accidentally mix a text string with a number, which will bring your program to a halt. In Python, variables serve as pointers. Think of them as sticky notes that mark a specific location where your data lives inside the computer's memory. Every piece of data has a unique memory tracking number, which you can check using the ID function. To save space, if you create 2 variables that hold the exact same small number, Python will point both sticky notes to the exact same memory address. This brings us to a crucial rule about text. In Python, strings are immutable. As you can see with this locked crate, once a piece of text is created in memory, its contents cannot be altered in place. You cannot swap out just one letter. Because that original text is locked down tight, modifying a word or a sentence requires Python to build a brand new object in memory. This is a built-in safeguard that ensures your raw data doesn't get accidentally corrupted while your program is running. Since our goal is to build a financial calculator, we need to do some math. Python handles addition, subtraction, and multiplication exactly as you would expect on a standard desktop calculator. Division has a specific quirk. On the left is standard division using a single slash, which will always give you a decimal or float. On the right is floor division using 2 slashes. Notice how it removes the decimal entirely, rounding down to the nearest whole integer. There is also a special symbol called the modulus operator, which uses a percent sign. Instead of dividing, modulus is used strictly to capture whatever remainder is left over after a division equation. Understanding these specific math behaviors allows us to write the core logic for the salary calculator with precision. Let's start building the calculator. We need to ask the user for 2 pieces of information, their current salary and the percentage jump they want. We do this using Python's input function, which prompts the user to type an answer. Here is a common pitfall. The input function captures everything the user types as a string. Python treats those numbers as plain text, so any attempt to use them for math will cause an error. To solve this, we use typecasting. As shown here, we take that text data and pass it through a filter called the integer function, or int. This converts the text into a solid, math-ready whole number. Missing this step is the most frequent reason beginner-projects break. If you want to perform calculations, you must ensure your data is stored as a number. The first phase of our script captures the current salary and the target hike. We take those user answers and wrap both in our integer function, so they are ready for the calculation. Next comes the calculation phase. We write a line of math to multiply the current salary by the percentage hike, giving us a new target monthly salary. Then, we take that result and multiply it by 12 to find the total annual package, which represents your total yearly compensation. Finally, we use a print command to combine our calculated numbers with a message, displaying the exact target package to the user. You have now built a working automated assistant. Before we wrap up, let's practice explaining what you just learned. Imagine you are in a technical interview, and the hiring manager asks, since Python is an interpreted language, does it compile code? And what exactly is dynamic typing? You can answer that by saying, Python compiles code into an intermediate format called bytecode, which the Python virtual machine then interprets line by line. Dynamic typing means variables are just pointers in memory. Python evaluates the data type automatically at runtime, so I don't have to declare it manually. Now it's your turn. Your homework for today is to write a script that asks a user for their age, converts it to a number, and calculates how old they will be next year. Try it out, and I will see you on day 2.